Hello everyone, welcome back to Deviations. In the last video we covered exponential growth and decay and how it had a relationship to differential calculus. Well, we're going to continue talking about some word problems, and today's focus will be on chemistry, and of course in following videos we will be covering the other natural and social sciences before we move off into Unit 3. So let's get started with the differential calculus applications to chemistry. And as always, I recommend that you go and watch my previous videos on differentiation if you haven't already, just because we will be using those topics extensively in this video. So we're going to start with an example out of James Stewart's early Transcendentals calculus book. This is from section 3.7, example 4. This says a chemical reaction results in the formation of one or more products from one or more reactants. This is the general idea of a chemical reaction equation. If you've taken a general chemistry class, you probably know what I'm talking about. So if we consider the reaction A plus B yields C, the concentration of a reactant A is the number of moles per liter and is denoted by A with the square brackets around it. And the concentrations are all functions of time. Transform the average rate of reaction equation to the instantaneous rate of reaction equation. Okay, so here is the average rate of reaction equation, and that says delta concentration C over delta T is equal to concentration C minus concentration C at their time intervals over T2 minus T1, and we're going to take the limit as delta T goes to 0 of delta concentration C over delta T, and of course the deltas become differentials and we get d concentration C with respect to time. Okay, and now we can use this to find the other expressions. So that will give us d concentration C over dt equals negative d concentration A over dt equals negative d concentration B over dt. Sometimes in these chemical reactions, though, we get these coefficients attached to the elements or compounds, and that's because sometimes we need to balance our reaction equation so that we have the same amount of products as reactants. And what we can do for this, to accommodate for this in our instantaneous rate of reaction, we can say negative 1 over A d concentration A with respect to time equals negative 1 over B d concentration B with respect to time equals 1 over C d concentration C with respect to time. Alright, so that's our first example. Let's do a little bit more involved example now. This is going to be example 5 from that same book, and this asks, if a substance is kept at a constant temperature, T denotes temperature, then volume, V denotes volume, depends on pressure, P denotes pressure. Consider the derivative of volume with respect to pressure as the compressibility when we divide it by the negative volume in this equation. Beta is equal to negative 1 over volume times the derivative of volume with respect to pressure. So that is the equation we're going to be using for this problem. Now we're going to get an expression. The volume of air at 25 degrees Celsius is related to pressure. In the expression, volume equals 5.3 divided by pressure. Okay? And now we are going to talk about a case where our pressure is going to be at 50 kilopascals. So that's 50 kilopascals. And now we are going to evaluate dV dP at pressure equals 50 kilopascals. If we differentiate this expression here, we're going to get negative 5.3 over p squared, and we are evaluating that at p equals 50. and that will yield negative 0.00212 meters cubed per kilopascal. Okay, now let's find beta, and of course beta entails multiplying our dV/dP evaluated at whatever value we want. In this case it was 50, and then we multiply that by -1 over volume. Okay, so now we will get beta is equal to -1 over V dV/dP when P is equal to 50 kilopascals. And if we do that out, it will give us 0.02 meters cubed by kilopascal by meters cubed. All right, and that was our last example. Not a terribly long video today, but it's important that we get these applications down for the word problems, and especially if you're going to be taking AP calculus test, these are going to show up a lot. Next time we will be back to talk about the applications to biology, which will be a really fun video. I'm excited for that. We will see you guys later. Thanks for watching. Please like it.